So today I'm going to be talking about detecting memory leaks in Node.js. My name is Dara. I work as a developer in nearForm. I do a little bit of DevOps kind of stuff for that. nearForm is a company based out in Tremor in Waterford. We do like Node.js for enterprise companies. So there's always really interesting stuff going on there, and we're always hiring as well, so get in touch if you're interested. Yeah, so you can reach out to me if you want by any of those means, ask questions or just have a crack. So yeah, moving on. The idea for this talk came from about 2 years ago. We published this blog post on the nearForm blog, and a lot has happened in 2 years. So there's like new features in Node, and there's new technologies. So that's me. I got the task of updating the blog post with new methodologies and tools and that, and then we realized it would actually make great content for a talk. So moving on, what is a memory leak, right? According to Google, a memory leak is a failure in a program to release discarded memory causing impaired performance or failure. So it's a pretty good definition, but I guess in the context of Node is a garbage collected kind of runtime. You don't look after the memory applications yourself, so it's just handled for you. So in that context, memory leak, I suppose, is a build-up of objects that are unused but are still referenced, so the garbage collector can't get rid of them. So today we're going to talk a little bit about the memory management, a little bit about the garbage collection, and then I'll do a small demo on actually how you can detect memory leaks. So let's talk about V8. So V8 is the engine that actually runs Node.js, right? And let's talk a little bit about the memory management that goes on there. So in V8, this is like a visual representation of your process in RAM, your node process in RAM, right? So this residence set is the entire chunk of memory allocated to your node process in RAM, and it's made up of a couple of different parts. You've got the code itself, you've got the stack and the heap. And the stack contains things like primitive types like booleans and integers and pointers to the objects that are in the heap. And it's also got like the execution stack. And then the heap, which is the part we're most interested in today, because that's where you find memory leaks. The heap is what contains objects and strings and closures and that kind of thing. So you've got some space allocated, and then you've got the actual space that's being used at any given time. So that's the high-level overview of memory in Node, and then you can kind of check out what's going on there with process.memory usage. So you've got residence set size, heap total, and heap used. So you can check that at any time. So moving on to garbage collection. With a bit of mental gymnastics, you could probably, it's a memory leak, right? It's garbage collection gone wrong. So if we actually look at the heap a little bit further, you've got what's called the young space and the old space, right? It's divided into these two spaces. The young space is a kind of small space where newly allocated objects are placed. It's only like 1 to 8 megabytes in size. And then in the old space is where objects go if they've lived in the young space for 2 consecutive garbage collections. So you've got 2 different kinds of garbage collections happening in those spaces. And basically, if an object survives in here for 2 collections, he ends up down here. And then to talk about that garbage collection just a little bit, scavenge, as I said, scavenge garbage collection occurs in the young space, right? It's frequent, it's fast, it's an implementation of something called Cheney's algorithm, which in a nutshell, it takes that young space, splits it in 2, copies all the live objects from one place to the other, and then just discards the other place, right? So it's very quick, but it's not very thorough. But funnily enough, only 25% of objects in the young space actually end up in the old space. So for the most part, they only live in the young space for a very short time. And then moving on, in the old space, we've got a very familiar sounding algorithm here. It's mark, sweep, and compact, which is a recursive algorithm that goes through every single object in memory, marks them as either active or inactive, and then the active guys stay and the inactive guys get removed. The thing about mark, sweep collection is it's a lot slower because it pauses all your JavaScript execution, right? So the thing about memory leaks is if your memory starts ballooning up, these collections start happening more frequently, and your program slows down big time. So you can actually look at the debug output from those garbage collection events with the trace GC flag. I can actually show you real quick. So I just have like a small little sample code here. It's all a memory leak, so it'll die very quickly. But you'll be able to see some like garbage collection events happening when I run it with the flag. So we can see some scavenge collections, and then we can see some mark sweep collections. I'll just stop that before it dies. So you can see some scavenge collections happen, and then you can see some mark sweep guys, and you can see like over time the memory is getting bigger. So what we have here is the allocated size of the heap and the actual amount of heap being used, and then after the garbage collection, it's gotten a lot slower or smaller, but over time it's still growing. So you can see that's possibly indicative of a memory leak, but it definitely is because I have the code. Which I will show you at the end. But moving on. So let's actually go find the memory, right? AKA demo time. So this is just one of the example leaks. It's like the basic hello world example you see on the Node.js website with a bit of modification. Can anyone tell what it is? It's pretty obvious. Yeah, so basically every time that server is going to get a request, we're going to add 1,000 listeners onto that server. So, right here, as you can see. So every request, it's going to add that 1,000 listeners. So if we hit our server continuously, just a load of times, it's going to start like ballooning up very quickly, okay? So that's a really trivial example of a memory leak, and that's the one I'm going to use to demonstrate the tooling we can actually use to look for memory leaks. But regardless of like how complicated or how simple your leak is, it's mostly the same process anyway, so it's all good. So basically how we can do it. What we do is we create snapshots of the heap at a given time, and we take multiple snapshots at different intervals, and then we can compare those snapshots to see what's going on. We can see growth in the actual memory used, and we can see the objects that are being created. And there's a bunch of tools out there, so I can't show all of them, but I'll show some of the ones that I looked at extensively. And they're kind of in the Node ecosystem as well. You can use a lot of low-level tools as well, but we'll keep it within the Node ecosystem today. So we've got these tools here: memwatch next, heap dump, the inspect flag, the trace GC flag, and the expose GC flag. So I've showed you this guy already. This guy actually allows us, gives us access to a global garbage collector object in our process, so we can actually manually call garbage collections if you want. The inspect flag allows us to debug our node process in Chrome, which is really cool, and I'm going to show that. That's a new feature since Node 6, so if you're using an older version, we've got a module called Node Inspector, which basically does the exact same thing, and it's really good. Then heap dump is a way for us to create snapshots from within the code itself. And then memwatch is a guide that can possibly give us events about memory leaks. So I have a couple of slides on those tools that I'm not going to show you. They're just there if you want to go and take a look at the notes later on. But I'm just going to skip ahead to the demo. So demo time. This is a nice short talk, it's great. My first talk as well. Yeah, so that's the code example you guys saw a second ago. Just make it a little bit bigger. Right, so can everyone see that perfect? So the first tool I'm going to show is MemWatch. That guy that was this guy, MemWatch. So we're going to use, it's called MemWatch Next because it's a fork of the original project called MemWatch, which is like severely outdated. But MemWatch Next seems to be pretty good. I've tested that up to Node 8 and it still works. And what it does is it kind of looks at the garbage collection events and then it defines a memory leak as being, you know, if your heap usage has grown over 5 garbage collections. So it's not like a, you know, you definitely have a leak, but it's probably a good indication. But yeah, sorry, it's really easy to use though. So we're just going to modify our code a little bit to add a listener using MemWatch that will tell us, you know, we have a leak. You could use this in your own code as well to find out. Okay, so we're going to run it now. So, our leaky server is this stuff here, leakyserver.js. So we're going to run that. And what we're going to do is just simply hit it with a loop, just constantly request, and that's going to cause this leak to happen. So we can see MemWatch is starting to give us this information. It looks like there's a possible memory leak detected, right? So that's just one tool. You could possibly use it in an application if you suspect maybe you have a memory leak. And that might help you just reaffirm that suspicion. And then now we'll use some actual tools to find it properly. So my favorite tool that I've found to do this is the inspect flag in Node. So is anyone unfamiliar with the inspect tool for Node? Have you all heard of it? Oh, tough crowd. Alright, I'll show you anyways. So inspect is really nice. It allows us to open up our whole process within Chrome. So we get this link that we can paste into our browser. Still causing leaks, one sec. I'll restart it. Right, so now we're in the essentially the Chrome debugger, so we can actually see the code of our application. You can see the console there. I'll make that a bit bigger. So this is a really great tool. It can help, like, it can be used for a lot of stuff. I'm just going to show you specifically though the memory related stuff. So under profiles, we've got this ability to take snapshots. So what this does is it creates this file. It's a dump of the entire heap at any given time, at the time that you wanted to take it, and it gives you like everything about what was in memory at that time, and it's really helpful if we take multiple snapshots because we can compare them. So I'm going to take a snapshot while the process is idle, and then I'm going to take a snapshot again after like 20 seconds. So that's a really small snapshot, it's 5 megabytes. Now we're going to start hitting the application. So just give it a few seconds. Just stop this so it doesn't blow my machine up. So we can see there's been quite a considerable growth in how much memory has been taken up instantly, but that's not exactly enough. We want to look at it closer. So looking at an individual snapshot is kind of hard to tell what's happening, but when you compare them using this comparison view here, it's like it's the best thing ever. So now we're comparing against snapshot 1, and what this does is it's going to show us the difference. It shows us the deltas between the time at snapshot 2 and the time at snapshot 1, and we can see a lot of stuff. So immediately we can see there's been a ton of new closure objects being created, and we can see like the size delta that's being taken up in our heap. And I mean, it's pretty obvious already. We've found a leak, so we can look a bit closer. You can see a ton of leaky funk objects, which is this guy back here. Because basically, every time we make a request, we're going to add a leaky function object guy onto our server, right, as a handler kind of thing. And so it's really cool because in this view here, we can actually dig deeper and see everything that's going on. And if we just take a look at this guy, this view here, down below, I'm going to stretch that up. The retainers view is really cool because what it does is it tells you the objects that have references to that object. So like, you can see the big list of references the whole way down that tell you like where this object actually exists, like how it ended up coming into existence. So you can see it's in a it's an element in an array somewhere, and it's attached, it's referenced by a request object inside this guy here called event handlers, all the way down inside our server, inside a socket. So it's a really cool kind of tool to look at because it gives you a really nice understanding of what's happening as well on a low level, which is kind of fun because you just gain a better understanding of everything. And then lastly, just as a nice little feature, if you hover over this guy, come on, you should be able to get where is it? Yeah, I don't know. But basically, it's funny, Chrome is just screwing me now. Basically, you can usually just like hover over any of the objects as well, and it'll give you like this little preview, and it'll tell you exactly what line, of code on what file that object was nuked into existence. So you can see exactly where in your code you accidentally caused a leak, which is really nice. So that's that section of the demo, I guess. Can I see? You can probably dig down in here too, somewhere. It's in there somewhere, I can't remember. But yeah. that's a way to find memory leaks, I suppose. And that's a really helpful way to find it in like a local development environment. You're not going to have access to your inspect flag, say if you've got code running in production or whatever. So maybe you need some other way of doing it, or maybe you want to be able to create those snapshots using code as opposed to manually doing it like I did there. So we can use this module called heap dump to do that for us. Dump is a really like well-respected module written by a really well-respected author. You can look up. I'm going to use it now. So what we're going to do is we're just going to tell heap dump to write a snapshot when memwatch thinks it's found a leak. Hopefully that's correct. Alright, so one more time. Usually we have something happening by then. Let me see. Okay, I don't exactly know what happened there, but when I killed the process, all of a sudden all the console output showed up. So it must have happened in the background. I don't know why it did. Maybe our leak was so bad that we couldn't write to the console, who knows. But we can see these files here. And, you know, like, you can create these files and then in Chrome, like, you can just open up, say, without using the inspect tool or whatever. If you want to open up your dev tools and go in here, you can load in those files really easily, so it's pretty handy. And then you can do the exact same kind of process that I just showed you, and that's really nice. And yeah, that's pretty much it for the demo, I guess. It's actually, it sounds like it's going to be a really kind of in-depth, difficult thing, but it's actually quite easy to do, and I think anyone can do it. I was so surprised myself how easy it was. So hopefully you learned something that you can actually take away from this talk today, and you can use it, because it's pretty good. And I guess the last little thing is just some final things to consider. Taking snapshots, so like that whole process of using heap dump are really expensive on CPU and memory. Like essentially, if your process is taking up X amount of memory, you have to have double that amount to actually successfully write a snapshot, and it essentially blocks your process as well. It's very expensive. So that's why you should probably try and find leaks in a test environment if you can. If you've got something that's kind of tricky to track down, try and simulate it somehow. Like the little loop that I showed you there, just making requests is a really simple example, but you might be able to use a tool to simulate requests to an application, for example, like Apache benchmark or something like that. And you might be able to inflate the size of your process that way. And hopefully you shouldn't have to try and find them in production then. So, but then I guess if you are going to try and find them in production, like for example, like MemWatch, or you could write your own tool as well. Like, I mean, the logic for possibly finding a memory leak is so simple. Like, it's just count the number of times the garbage collection happened, and then if your heap is after getting bigger, just possibly we have a leak, right? So, like, if you have a tool to check that kind of stuff, make sure that, you know, humans actually get alerted by it, so you're aware of it happening. And then, yeah, so I guess that's kind of ties in with what I said again, is, you know, MemWatch is just an example, but there are so many other ways you can check this out yourself. Like, I mean, you could probably write something to do what MemWatch does in like 30 lines of code or less. And then lastly, beware of false positives. So, like, you know, sometimes we do write applications that have high memory usage, or they have spikes in memory usage, depending on what's going on. Like, just because your memory is inflated for X amount of garbage collections doesn't necessarily mean you have a leak, so maybe it's not all bad. And that's it for me. The end. So does anyone have any questions, or?
You said that you're trying to monitor the relocations and leaks. Is there any particular solution to use that matches well in Node?
Say again, come again.
Node used to monitor leaks in Node. Is there a specific solution? Are there like APIs that you prefer to use?
Yeah, so like, just as an example, right? Like, if you wanted to, as I said, right? Like, basically, one approach is just see how many see when the garbage collections are going on, and take a look at the heap usage at the same time. So the process memory usage is a really handy one just for seeing what your heap usage is like at a given time. And if you want to use like the expose GC flag, you can manually call those garbage collections, and then immediately after that garbage collection happens, you can check the memory. So you could like put a counter on it or something, and just you could roll your own tool really easily without other like APIs, just to see what's happening, and then, you know, log it somewhere. Just log it somewhere so someone hopefully sees it. You know.
Are there agents that use these techniques and publish metrics to services like, I don't know, a watch or Datadog?
Yeah, that's a good question. I'm not really fully aware. If someone does know of any, I'd love to know, though, to be honest, or like tweet me or something. I'm sorry I can't answer that very well.
Thank you.
Any other questions?
Yes, sir, I have a question. Could you also use, this is the point, sorry. Could you also use some kind of operating system level, you know, tools to measure Node.js process to find memory leaks? For example, if you have, you know, Docker and or a bunch of Dockers, and you have to check them from the kind of, rather than from the JavaScript layer, from, you know, use operating system tools for that.
Yeah, there are a bunch of tools. You can take, they're called like core dumps, which is like, it's not like a heap dump, but it's like an entire dump of your process, and then you can use, there's a couple of really, much lower level OS kind of level tools you can use to debug. I knew I'd get asked that as well, but I kept it out of the scope of today's talk. But
Sorry.
there is, who is it? There's a Netflix talk. I'll put the link in the into my slides. There's a Netflix talk from this engineer from Netflix, and his talk is like an hour long, and he goes through everything. It's just amazing. Like he goes really low level. So if that's what you're looking for, I'll put it in there.
Thanks for that.
All right, I think that's it. Thanks very much for having us tonight. major thanks to Intercom and to nearForm for giving us food and for giving us the venue, and thanks for listening to me as well. My first talk, I'm so happy.